Hey, this is Doug with Design 8 Studio. I'm making a quick video to help explain focal length in CO2 lasers. Some members of the V1 Engineering Forum are considering what to buy and inquiring for better understanding about focal length. So there's a concentrating lens that takes a straight laser beam and focuses it down to make it concentrated at a point. And the focal length is the distance from that concentrating lens to where that point happens. Now, just for comparison, this Cloudray E series is set for 63.5 millimeters of focal distance, but there's another option that's set for 50.8. So just for round numbers, I'm calling it 63 and 50. Okay. Now you'll notice that there is a kind of a cone screwed onto the end, and that's where the air assist gets routed in. And I've tried to kind of illustrate that a little bit in this drawing in CorelDRAW. Now, just to show you here, this focusing lens is illustrated in orange and the laser beam is illustrated in transparent red. And on the left side, you see the 63 millimeter focal distance. And on the right side, you see the 50 millimeter focal distance. Now that tan looking rectangle represents your material that you're cutting. And oftentimes, if you align the very sharpest point of the laser on the top of the material, which is really advantageous for engraving, you get a good result. But if you're trying to do a through cut, then oftentimes what you want to do is deliberately position the material that you're cutting so that the laser, you want to adjust your laser down further so that that focal point is striking in the middle of the material that you're cutting. And as you can see, with a 50 millimeter focal distance, you can wind up tapping the laser head against the material before you get that depth. Everything that you see here is actually drawn to scale as far as the focal lengths are concerned. And I'm not positive if the rest of it is to scale, but it's pretty close. And so there's another thing to consider, and that is that the amount by which the concentrated laser beam spreads out again on its way past that point of smallest dot. On a longer focal length, it takes longer for it to splay out further, but on a shorter focal length, it's going to concentrate faster and it's going to splay out faster. These are reasons why folks prefer a longer focal length over a shorter one. Again, this has been Doug with Design 8 Studio, and I hope this has been helpful. And until the next video, I wish you happy making.